Hi, good day. My name is Imiji and my matrix number is DD220070. I'm the group leader for Section 1 Group 2 of BDA 10602 Creativity and Innovation. The title of our assignment 3 is Renewable Source Polymer Transforming Waste Oil into Eco-Friendly Materials. So here is our team members including Elia Fakiha, Eng Shaotang, Fatin Noor Aisha and Haikal. So here is the overview of our presentation, which includes introduction, creative problem solving, idea description, product development process, business, finance and marketing plan, and conclusion.
Hello, my name is Eng Tang. I'm going to continue the introduction of our project. As we all know that the plastic are widely used but have negative environmental impact, as the traditional plastic do not easily break down, it leading to non-biodegradable waste accumulation. The biodegradable mulching film is a sustainable alternative to plastic film in agriculture, as it is made out of the special polymer that can break down into the harmless substance. The biodegradable mulching film can help reduce the microplastic pollution and protects soil quality and ecosystem. It represents a significant advancement in the material science. By using this innovative product, we can work towards a more environmentally friendly and sustainable future. Engineering plays a crucial role in finding solutions to global challenges like the plastic pollution. For the problem statement of the project, the first problem statement is the plastic are extensively utilized in agriculture, whether it's for constructing greenhouse or directly applying them to the soil as mulching film. However, this widespread use raises concern about the potential impact of microplastic on soil quality. The second problem statement is the degradation of degradable polymer films can be influenced by various environmental factors such as temperature, humidity, and also the microbial activity. However, achieving consistent and predictable degradation rates can be challenging, leading to variability in film performance and lifespan. Ensuring reliable degradation under diverse agricultural conditions is essential for optimal film functionality.
My name is Elia Fakiha, so I'm going to explain about the creative problem solving. There are 6 types of creative problem solving. The first step is to identify the goal, wish, or the challenge. First is to create biodegradable polyurethanes from vegetable oils and evaluate their severity. Second is to investigate the degradation of the polymers in different soil, medium, assess their thermal stability and develop sustainable polymer composites to protect against UV degradation and enhance the mechanical properties. Second step is the fact finding or gather data. First one is who, which is immersion student, and then what they do, process of creating biodegradable fuels from vegetable oils, and evaluating the stability through the various experiments. When? From 20 March to 31st May of 2023, where in the lab Rendas as Maramua. Why is to understand the synthesis and stability of biodegradable fuels from vegetable oils and find the ways to improve the performance. How? By exploring the methodology and technique used to synthesize the fuels, test them in different soil medium, and evaluate their stability through weight loss, pH change, and thermal exposure experiment. How much? Measure and quantify the change in weight, pH, and mechanical properties of the polymer films under different conditions such as UV exposure and soil degradation. Step 3 is to clarify the problem or problem finding through the data gathering. The way to evaluate the stability of biodegradable polyurethanes from vegetable oils are through tested in different soil mediums and weight loss and pH change indicated degradation. Step 4 is generate idea. There are 6 categories of idea finding. first category is machine. The cost detail is mixing, curing, and film formation process. Optimize the mixing parameters such as speed, time, and ensure the consistent curing conditions. Regularly calibrate and maintain the equipment. Second is the materials. The cost details is virgin and waste protein or waste polymer. So we conduct through material testing and selection for optimal stability and explore alternative materials with improved performance. The third one is manpower. The cost of the detail is researchers conducting experiment and tests. So we provide the extensive training and expertise to researchers involved, regularly update knowledge and skills in the field of the study. Next, the cost category is measurement. The cost detail is gap loss and phase change indicate the degradation. The countermeasure idea is implement accurate and precise measurement techniques for ingredient and ratios. Conduct regular quality control checks. Other than that, the cost category is the environment. The cost detail is soil medium, compost soil, and peat soil. The countermeasure idea is conduct comprehensive soil analysis to understand the degradation mechanism. Then optimize formation for specific soil condition. The last category is the cost detail is thermal exposure experiments. We can countermeasure it by control the temperature and duration of thermal exposure to minimize the degradation and explore the alternative curing techniques for quality. Step 5 is the select a strengthening solution. I will call it solution finding. There are 6 categories and the countermeasure ideas. So for this step, we have criteria 1 until 5 rating. So for the measurement, the total mark is 11, environment 11, method 9, machine 11, materials 10, and the manpower is 13 marks. The last step is step 6, which is plan for action or acceptance finding. So there are 3 goals, which is immediate, short, and medium. So the immediate one, within 1 week, reporting completion to the MRSM teacher. The short course is within 1 month, also reporting completion to the MRSM teacher. And last one is medium. The due date is before 1 May, and reporting completion also to the MRSM teacher.
Hi, Assalamualaikum. My name is Haikal bin Mahmud Azmi. My registration number is CD220184. For idea description, there is 5 parts or sections. Introduction, environmental friendliness, control degradation, enhance soil health, simplified disposal process. Introduction. The environmental impact of microplastics on soil quality is a growing concern. Introducing a groundbreaking solution, biodegradable mulching film. This innovative product addresses environmental concerns and offers numerous advantages for farmers and the environment. Environmental friendliness. Composed of carefully selected biodegradable polymers, reduces the risk of microplastic pollution and minimizes long-term soil and ecosystem impact, offers a sustainable alternative to traditional plastic mulching films. Control degradation. Incorporates additives for predictable and consistent degradation rates. Responds to environmental factors like temperature, humidity, and microbial activity. Maintains optimal film functionality while ensuring environmentally responsible degradation. Enhance soil health. Promotes organic matter in the soil as it degrades. Fosters nutrient cycling and beneficial microbial activity, improves soil structure, moisture retention and fertility, leads to healthier crops and increased yields. And lastly, simplified disposal process. Biodegradable nature allows ploughing into the soil or composting with crop residues, eliminates the need for separate collection and disposal, reduces labor and waste management costs, contributes to sustainable agriculture practices. For product development process, as you can see here, start and then problem identification, creative problem solving, idea description, preparation of thin film degradable polymer. And there are 7 testing methods here. First is hydrolytic degradation, soil burial test, thermal degradation, visual and microscopic observation, ultraviolet irradiation exposure, tensile test, carbonyl index. Then we go to result, analysis and discussion, then it ends. Thank you.
Now I will present about the methodology of this project, which explaining the 6 methods applied in order to test the degradable polymer from different properties. So before we proceeding to these 6 methods, we need to prepare the thin film degradable polymer. So how to prepare the thin film degradable polymer? It is prepared from mixing between renewable resources of waste cooking oil, MDI, 10% titanium dioxide by using mechanical stirrer and cast into the container. After it dry, we can peel it and become the thin film of degradable polymer. So the first method is hydrolytic degradation. Hydrolytic degradation describes how materials break down chemically when they interact with water molecule. The water will break the chemical bonds in the materials, making it weaker and changing its properties. So the procedure is weight the initial weight of the thin film, submerge the thin film in distilled water, and after 10 days, dry it in the oven for an hour and weigh it again. So from here we can calculate the weight loss of the thin film. So the next method is soil burial test. It is conducted by locating the polymer film on the surface of the topsoil, and we measure the height of the seedling and the weight loss of the thin films. The third method is thermal degradation. The purpose is analyze how virgin oil polymer and waste oil polymer thin film change when exposed to different temperature. So the temperature in this testing was 50, 100, 150 and 200 degrees Celsius for 5 hours in an oven. So by comparing this peak area in the FTIR spectra, the carbonyl index can be calculated, which is used to assess the change in the chemistry of the thin film. The next method is visual and microscopy observation. The film degradation causes the surface roughness, formation of hole of spits, fragmentation, color changes, and development of biofilms on the surface. The electron microscopy was utilized to investigate the degradation mechanism and collect the data. For ultraviolet irradiation exposure, the BP and BPC thin film were UV exposed at 50 degrees Celsius by using UV fluorescence lamp for a certain hours. And the purpose is to analyze changes in mechanical and physical properties over time. The last method is tensile test, which is performed by using universal testing machine. The test involves measuring the tensile strength, elongation, and strain. So now I will present about the result and discussion for the methods that I explained just now. For biodegradation and hydrolytic degradation, from this graph, we can know that the blue color indicates the hydrolytic degradation, the red color line indicates the soil degradation for peat soil, and the green line indicates the soil degradation of compost soil. So based on this graph, we know that the compost soil degrades polymer thin film more than the peat soil. This is because the environment factors like bacteria and fungi in the compost soil erodes the surface and initiating the degradation. The waste oil will become saturated during heating and the triglycerides in the oil can be biodegraded. So this graph indicates the change of pH value. So the initial pH value of the soil and water is stated here. After 50 days, we found that the compost soil become neutral and the pit soil remains slightly acidic and the water becomes slightly acidic over time. In short, the polymer degradation produces low molecular weight acid that may affect the pH. So the next one is thermal degradation measured by CI. So this is the FTIR spectra of virgin oil polymer during unheated and heated oven thermal exposure at 100 degrees Celsius and 200 degrees Celsius for 5 hours. So generally, the Carbonyl index was used to measure the level of heat deterioration in the polymer thin film over time. So the VOP has the highest CI and the WOP has the lowest. Therefore, WOP has higher thermal stability compared to VOP, which leads to slower degradation under high temperature conditions. The next one is visual observation of biodegradation of thin films. So this one is for the soil barrier test and this one is for the hydrolytic degradation. So from this soil barrier test, we found that it undergoes color change and turning the color from yellow to dark and the particle becomes smaller. After 50 to 60 days, the microorganism cause cracks and splits. Because the microorganisms play a significant role in breaking down the polymer bonds during biodegradation. So this hydrolytic degradation shows minor tears and splits at the film edge. Besides is the morphological change of polymer thin film by optical microscope. So the microscopic studies are necessary to observe the initial attack site, pattern and nature of microbial degradation activities. So for the soil barrier test, the polymer film are buried in the soil for 20, 40, 60, 80 and 100 days and we can know that the surface become rougher and showing more degradation. After 80 days, the surface become heavy colonized, losing its smoothness and become black. On the other hand, for the hydrolytic degradation, it results in fractures and empty spaces as polymer change break. So for the last one is the mechanical properties of PP and BPC upon the UV irradiation. So these two graphs indicates the tensile strength against UV irradiation time for BP and BPC of VOP and WOP. So the tensile strength of the BP and BPC film will decrease when the irradiation time increase. Therefore, in short, the tensile strength of the VOP film is higher than the WOP film. So in short, based on the result in discussion part, we know that the WOP waste oil polymer degrades faster than the virgin oil polymer. This is because WOP contains impurities and contaminants that can accelerate the degradation. Besides, the WOP can degrade faster in water compared to soil. This is because the water environments typically have a higher microbial population and diversity. Last but not least, waste oil polymer degrades faster in compost soil compared to pit soil. This is because compost soil is rich in organic matters and nutrients which provide a favorable environment for microbial activities and promote the degradation. So that's all from me. Thank you.
And now we can look at the slide presented. Here is the engineering drawing for mulching film. The material used for making the mulching film is biodegradable polyurethanes, which is commonly called as PUS, from vegetable oils. The thickness of the mulching film is 100 micrometer. The width and length of mulching film is 1.2 meter times 5 meter. And we can know that the mulching film takes 6 months to undergo the degradation process. And the strength and durability of the mulching film, it can withstand the installation process, environmental stress, and also the regular agriculture activities. The UV resistance of mulching film is the incorporated additives to ensure adequate UV resistance. It can prevent the premature degradation when exposed to sunlight. And last but not least, the water permeability of emulsion film. It allows for appropriate water permeability, enabling irrigation and preventing waterlogging.
My name is Fatin Aisha. Now I will explain the last part of the project, which are business, finance, and marketing plan. It is divided into three main points, which are market and commercial potential, finance, and lastly, marketing plan. Okay, so now we will go through with the marketing plan first. The first point stated are the growing demand of eco-friendly polymers for environmental sustainability. Products such as waste cooking oil, biodegradable polymers are preference for sustainable product. Next is market size and potential. Biodegradable polymers are expected to increase rapidly in incoming years to protect the earth from harmful substances like plastic. It will be in demand as the government and organization implement regulation to minimize plastic waste. Other than that, environmental benefits. This product acts as renewable energy. It biodegrades into harmless byproducts. Next, a strategic connection with environmental organization also can help the product become market leader. And lastly, with marketing and branding, the product can promote biodegradability, renewable resource, and low environmental effect. Other than that, engage customer with educational program, social media presence, and customized messaging to increase awareness and demand. As for financial support needed for this project are as above. Waste cooking oil that costs us nothing, 50 grams of methylene which costs us 242 ringgit 70 cent, and 1 kilogram of titanium dioxide which costs us 7 ringgit. Lastly, we will go through the marketing plan. Firstly, what we can do is to distribute the creative and attractive flyers to educate people about the benefit and quality of the product. We can also capture their attention with high quality images and simple messaging and emphasize the application in packaging. Next is to create a social media campaign and target audiences from various platforms to promote the degradable polymer products. Make some infographics, use hashtags, and connect with experts in industry to increase reach. Lastly, by online advertising, it also helps to expand our audiences. We can use online adverts to show the benefits of our products. So this is the brochure that will be used to promote our biodegradable products, complete with all of the information and good infographics. So lastly, as a conclusion, for environmental benefits, the film is composed of biodegradable polymers that degrade into non-toxic components, reducing the risk of microplastic pollution, and it also offers controlled degradation, ensuring a consistent and predictable degradation rates under diverse agricultural conditions. Other than that, under unique combinations, the biodegradable mulching film stands out from conventional plastic mulching films due to its unique combination of biodegradability and controlled degradation. It also provides practical and eco-friendly solutions while addressing the drawbacks of traditional films. And lastly, the conclusion in business potential is the biodegradable mulching film has promising market opportunities. Its environmental friendliness, soil health benefit, and compatibility with diverse agricultural practice make it appealing to farmers seeking sustainable solution. Thank you. That's all for me.